Welcome to the lecture on mathematical methods in physics. In today's lecture, we are going to deal with the spatial orthogonal coordinate systems. So today's point is spatial orthogonal coordinate systems. So this is today's point, spatial orthogonal coordinate system. First spatial coordinate system is Cartesian coordinate system. Now we are going to compare Cartesian coordinate system with orthogonal curvilinear coordinate system. So as we know, in orthogonal coordinate system, u1, u2 and u3 were the coordinates, right? And you know that in a Cartesian coordinate system, x, y, z are coordinates. So by observation you can say u1 is x, u2 is y and u3 is z. Similarly, E1 cap, E2 cap and E3 cap were the unit vector in orthogonal curvilinear coordinate system, and if you compare you will understand that E1 is I cap, then E2 is j cap and E3 is k cap. If I want to write an expression for r bar, which is a position of vector of some point p in, if this is Cartesian coordinate system, okay, and this is some point p, then r bar is a position vector of that point p, and I can write r bar as, so this will be x coordinate, this will be y coordinate, and this will be z axis, right? X, y, z axis, and I can write r bar is equal to x I cap plus y j cap plus z k cap. Now, in earlier lectures we saw that there are matric coefficients which are given by g11, g22, g33, and you can obtain them by differentiating with u1 dot dabba r bar by dabba u1. So this was the expression for obtaining matric coefficient g11, which is equal to mod of dabba r bar by dabba u1, a square of that, right? Because you are taking a dot product of the same vector, so it will give you mod and the square of that mod. So this will be the expression for matric coefficient. If you try to find matric coefficient in case of Cartesian coordinate system, so g11 will be dabba r bar by dabba x dot dabba r bar by dabba x. Now what I will do, I will find the dabba r bar by dabba x. So I have to just differentiate with respect to x to r bar. You know the value of r bar, that is x I cap plus y j cap plus z k cap. If you differentiate, let us differentiate. If you differentiate x, it will be 1 and then I cap. If you differentiate y with respect to x, then it will be 0, and again if you differentiate z, it will be 0, right? Then I want to take a dot product of dabba r bar x with dabba r bar by dabba x, right? Then it will be I cap dot I cap, and you know I cap is a unit vector, so its magnitude is 1, and if you take a dot product, its value will be 1. Then I can similarly find that G22, which is delta r bar by delta y dot delta r bar by delta y. If I work out, you have to just do delta r bar by delta y, then you can see if this is not x, this is y, then this term will cancel, this term will cancel, derivative of y with respect to y is 1, so it will be just j cap, and then again if I take here, then it will be j cap dot j cap, which is equal to 1. Similarly, G33 will be delta r bar by delta z dot delta r bar by delta z, and which will be equal to k cap dot k cap. Remember, you have to just differentiate r bar, so you can see the value of r bar. Our expression for r bar is xi cap plus yj cap plus zk cap. You have to differentiate this r bar with z, and you have to take dot product of the similar things. Then you will get again 1 over here. Now we have seen, if you are interested in finding scale factors which are given by h1, h2 and h3, then there is a relation between matric coefficient and scale factor, which is h1 is equal to root of g11, h2 is equal to root of g22, and h3 is equal to root of g33. You know g11, g22 and g33 are 1. This is g11. G11 is 1, G22 is 1, and G33 is 1. So if you put, it will be root of 1, which is equal to 1. Similarly, H2 is equal to root of 1, which is equal to 1, and H3 also root of 1, which is equal to 1. So what I can say, H1 is equal to H2 is equal to H3 is equal to 1. So this is what I have got. Let us quickly summarize what we did. Okay, so here we compare Cartesian coordinate system with a special, this is a special coordinate system, and we compare Cartesian coordinate system with orthogonal curvilinear coordinate system, where I got that u1 is x, u2 is y, and u3 is z. u1 cap is I cap, u2 cap is j cap, and u3 cap is k cap. And then I found the scale factors by finding the matric coefficient. These are the matric coefficient, and I found the scale factors, which is h1 is equal to h2 is equal to h3, which is equal to 1. So all scale factor in Cartesian coordinate system are 1. We are going to use them in upcoming sessions, but for the moment we will stop here with h1, and we will start with cylindrical coordinate system. So another spatial coordinate system is cylindrical coordinate system. You know the coordinate of cylindrical coordinate system are rho, phi and z. These are the coordinates of cylindrical coordinate system. Then I can say that u1 is rho, right? u1 is the coordinate of curvilinear coordinate system, or more specifically orthogonal curvilinear coordinate system. Then u2 is phi, and u3 is equal to z. I also want to find the unit vectors e1 cap, e2 cap and e3 cap. These are the unit vector in orthogonal curvilinear coordinate system. I will draw the diagram of cylindrical coordinate system, and we will try to find e1 cap, e2 cap and e3 cap using this diagram. So this is x coordinate, this is y coordinate, this is z coordinate, and I have to draw a cylinder. So this is a cylinder. This is origin. I will call this origin O. This is our first coordinate, rho, which is the radius of cylinder. Then if I take a perpendicular from the end of rho to the xy plane, and if I join that perpendicular to the origin, I will get some angle, say phi. This is our second coordinate. Angle phi is our second coordinate. And height of the cylinder. Height of the cylinder, z, is third coordinate. So you can see rho, phi, and z. Now, even cap, which is the first unit vector, will represent the direction of increase of rho. So if you see rho is going to increase in this direction, so I will call it E rho cap. Okay. So first unit vector is E rho cap, which denotes the direction of increase of rho. Similarly, if I name this plane O, M, L, and suppose this is M, okay, this is M, then you can see this plane can rotate around this z-axis. So it can go like this, right? So this is a direction of increase of phi. So I will call that E phi cap. This is a unit vector which denotes that in which direction phi is going to increase. So this is E phi cap, which is the second unit vector. Now third unit vector will be in this direction, z direction, which will denote in which direction the height of cylinder may increase. So that is the third unit vector, which we will call Ez cap. I am just putting the suffix instead of 1, 2, 3, you can see, to make them specific. So if you see that it is a E rho cap, it is E phi cap, and it is Ez cap, you can say that these are the unit vectors in cylindrical coordinate system. I got the unit vectors. What else do I need? I need scale factors. Okay, I am interested in finding scale factors. How can I find them? Okay, in order to find the scale factor, I need to find matric coefficients. So first matric coefficient was given by G11, which was delta R bar by delta U1 dot delta R bar by delta U1. Here you can see U1 is a rho, so it will be delta R bar by delta rho dot delta R bar by delta rho. Okay, so I need R bar also. You know, the expression for R bar in Cartesian coordinate system was x I cap plus y j cap plus z k cap. This was the expression. Now I cannot use this expression directly, so I have to put the values of x and y and z, which are in terms of this another coordinates of y, z. Okay, we have did it. We have found the transformation equation. So I can write that transformation. X is equal to rho cos phi, then y is equal to rho sin phi, and z is equal to z. So these are the transformation equation. I'm going to put these values of x by z in this equation. I will call this equation 1. Then I will get the R bar. So that R bar will be, I have to put the value of x, so rho cos of phi I cap plus rho sin of phi, value of y from here, rho sin of phi, and then there is a unit vector j cap plus value of z. Z is as it is. You can see the transformation equation does not change the z. So z k cap, but this is happening in case of cylindrical coordinate system. So I got the expression for R bar. This is the expression for R bar in cylindrical coordinate system. I want to find matric coefficient G11, G22 and G33. First I will find G11, but in order to find G11 I need to find this quantity, delta R bar by delta U1. U1 is rho, so delta R bar by delta rho. I will do it explicitly. So I need to put the value of R bar, rho cos of phi I cap plus rho sine of phi j cap plus z k cap. Now if you see, there is a rho cap in first term, there is a rho cap in second term, but there is no rho cap in third term. So in differentiation, third term will vanish. So what will be its differentiation? It will be cos phi. Cos phi will be as it is because it does not contain rho. Then I cap. Here again derivative of rho will be 1. Here also derivative of rho is 1 with respect to rho, right? Then it will be sine of phi j cap. Again I'm going to explain what I did. I took a derivative of rho cos of phi with respect to rho. You can see cos of phi does not contain rho, so it will be treated as constant, and derivative of rho will be 1. Similarly, derivative of rho here will be 1, sine of phi will be constant, j cap, its direction, it does not contain rho, so it will not get affected, it will be as it is. Now if you take derivative with respect to rho, here you can see z is, so it will be 0 because z is not dependent on rho in any way, so it will be 0. So derivative of z with respect to rho is 0, right? So I will get this expression for delta R bar by delta rho. Similarly, we will work out for the expression of delta R bar by delta with respect to U2. Here it is U1. For second G22 I will require U2, which is second coordinate, which is phi. So I will differentiate delta R bar by delta phi. So if you differentiate, I'm not going to write it like this again. Okay, we will directly see from here. Rho will be as it is, right? And the derivative of cos of phi. Okay, let us do it explicitly. Delta by delta phi, so that there will not be any confusion. Rho cos of phi, I'm putting the value of R bar I cap plus rho sine of phi j cap plus z k cap. Okay, what do you see from here? If I differentiate this, rho is a constant, so it will be outside, because this time I am differentiating with respect to phi, and derivative of cos phi, it is minus sine phi, and I cap will be as it is plus rho derivative of sine phi is cos phi, j cap will be as it is, derivative of z with respect to phi, it is 0, so it will not be here. So this is for delta R bar by delta phi. Okay, so and delta R bar by delta z, third coordinate, what it will be? Again you have to differentiate this quantity. This is R bar with respect to z this time. Okay, you are going to differentiate with z, so here it does not contain z, so first term will be 0 plus second term it will be 0 derivative, and derivative of third term, derivative of z will be 1, right? And you will treat k cap as a constant, so it will be just k cap, right? Okay, so I will highlight this. This is what we found, then this is what we found, and this part. Okay, and these we are going to use now in order to find matric coefficient G11, G22 and G33. Okay, so we wanted to find G11 and it will be like this. I just wrote it, delta R bar by delta rho dot delta R bar by delta rho, and we have found here delta R bar by delta rho is equal to cos phi I cap plus sin phi j cap. So I'm going to carry it here, cos phi I cap plus sin phi j cap. So you can see if I take a dot product, with again deba r bar by deba rho with itself. You can say cos phi into cos phi, it is cos square phi, sin phi it is sin square phi. So sin square plus cos square, right, the same angle, you can say it is 1. So what I got, g11 is a 1. Then we will find h1, which is root of g11, sorry, and it will be 1 because root of 1 is 1. So I found h1 is equal to 1. I will highlight it. Then we will try to find h2. For that I need to find g22, which is deba r bar by deba phi, this time phi, deba r bar by deba phi, because second coordinate is phi. So I will write it on next line. Deba r bar by deba phi is, you can see here, deba r bar by deba phi is minus sin I cap and then rho. Okay, I will write it here. Rho sin phi I cap plus rho cos phi j cap. And you are taking dot product with itself, then again the same quantity, sin phi I cap plus rho cos phi j cap. What do we get? It will be rho square, rho into rho is a rho square, negative, it will be positive, and then there will be sin square phi plus, remember whenever we are taking dot product, direction will not be there in dot product, okay? That is, we will get only the scalar as a result of dot product, okay? But while taking dot product, there are direction, but result will not contain any direction. Okay, here rho cos phi into rho cos phi, so it will be rho square cos square phi. If I take rho square common from this quantity, what I will get? Rho square sin square phi plus cos square phi. So this will be rho square, and I know this is g22, and h1 can be obtained by taking root of g22. So root of rho square, which is rho. So okay, I'm sorry, I should say h2. So h2 is equal to rho, right? Okay, I will use so that we could highlight it. h2, I got second scale factor, and third one is h3, which is g33. Okay, this will be deba r bar by deba z, third coordinate is z, into deba r bar by deba z. You know, we have found the expression. Again, we will refer the page where deba r bar by deba z is a k cap. So I will put here k cap dot k cap. These are the unit vector. You are taking the dot product of unit vector. It will be 1. So it is 1. Now h3 will be root of g33, which is equal to root of 1, and which will be 1. So h3 is equal to 1. Fine. I found 3 scale factors. They are like this. So h1 is equal to 1. h1 is 1. h2 is rho, you can see here, and h3 is equal to 1. So these are our scale factors. Okay. We'll change the page. Quickly we will try to find the unit vectors in terms of ijk coordinate. So how I can do that? Okay, just a moment. Okay, here I will start it. Deba r bar by deba rho. I can write it like this. Deba r bar by deba rho, and it can be written as rho cap, e rho cap, because you know this is a vector and its direction will be in E row cap direction, right? Then I can find E row cap. You just need to pull it to another side, so it will be delta r bar by delta row, this one, divided by delta r bar by delta row. Okay, what we know that delta r bar by delta row, again we will refer the page, and where it is cos phi I cap plus sin phi j cap. So I will write it here, cos pi I cap plus this one sin phi j cap. And if you see the magnitude of this vector, it is 1, right? Delta r bar by delta row is equal to 1. We have found it already on the last page, that if you take a dot product with the same vector, okay, it is nothing but giving you direction. It is something like this, delta r bar by delta row and square, and you can see it is equal to 1. So if I take a root of that, it will be 1. So I have to divide it by 1. So E row cap is cos of phi I cap plus sin of phi j cap. Similarly, I want to find E phi cap, which will be delta r bar by delta phi divided by delta r bar by delta phi. This time it is like this. So this one minus rho sin of phi I cap plus rho cos of phi j cap, and you have to take the magnitude of this. It will be rho square, right? And then, so taking a magnitude means taking a dot product with itself. So we have done it here. It is rho square, right? We took a dot product with itself, and then we took rho square outside, then we got rho square. Rho square is a square of magnitude, so here it will be only rho because it is root of rho square. Okay, I will write it like this, rho. So you can see rho will get cancelled. Okay, here rho will get cancelled, and you will remain with sin of phi I cap plus cos of phi j cap. So this is E phi cap, and then what I am doing here, I am trying to find unit vectors in terms of another unit vectors I cap and j cap. So here I found E phi cap in terms of I cap plus j cap, right? Now third unit vector is Ez cap, which will be equal to delta r bar by delta z upon mod of delta r bar by delta z. You know, delta r bar by delta z is k cap. Here you can see it is k cap. So k cap divided by delta r bar by delta z. Magnitude of a unit vector, it will be 1. So you can say Ez cap is equal to k cap. Okay, these are the three expressions we found. Okay, and the last. So finally, what we were doing at the end, we were trying to find the unit vector in cylindrical coordinate system in terms of unit vectors in Cartesian coordinate system. Okay, for today we will stop here.